Capybara, 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 capybara. Today we're going to dissect capybaras. I'm telling you right now, stay until the end because we're going to do something you've never seen in your life. Capybara overvolting, which translated means putting more voltage, more volts into a motor, into electronics, to improve performance, in this case, in the capybara itself. Everyone's obsessed with capybaras. Plushies are taking over China, Japan, and 25 de Marzo in Sao Paulo. I looked into the trend, but no one really knows exactly where it started. But one explanation is that capybaras are gentle animals. You look at a capybara, and it's just there, calm, zen, giving a ride to a BMT. Another explanation is that they have a weird kind of cuteness. Not exactly beautiful, but definitely cute. Brazil has its own capybara hype too, since the animal lives mainly in South America. Capybaras used to be found all over Brazil, but they were hunted and eaten. When I was a kid, neighbors would want to eat any capybara they saw. There isn't much meat on them. Now that people don't hunt them anymore, capybaras are coming back. Here in Sao Paulo, I'm near the Pinheiros River, where lots of capybaras live along the banks. The bike path along the river is already nicknamed Cicla Capivara because there are so many capybaras there. So it's great that there's hype around an animal that's basically Brazilian. But what exactly is this animal? The capybara is the largest rodent in the world. Rodents are a group above families, so there are several different rodent families. They're animals with front teeth adapted for gnawing, like rats, pacas, agoutis, beavers, and guinea pigs. I checked Google Photos and found a capybara picture. Then Pasca, basically a mini capybara, showed up. If you want to learn more about this classification, check the inverted pyramid on page 39 of our biology book, which explains species, genus, family, order, class, and more. But along with the capybara hype, one of the plush toys that's trending is this cute little creature right here. And when you switch it on, it starts hopping around, looking more like a rabbit than a capybara. It wiggles its snout and even makes this little sound that I seriously doubt has anything to do with a capybara. Its head also lights up with a red LED, and honestly, it's kind of weird. But it even comes with a little tortoise backpack, which is pretty cool. Because capybaras really are water animals from marshy areas, so they live around turtles and tortoises. Capybaras sometimes carry other animals on their backs. I've seen BMTVs riding capybaras here along marginal pinheiros. I searched for photos of a turtle riding a capybara, but instead I found the opposite. It was a capybara riding on a turtle's back. This actually seems fairly common, and if you think about it, there are turtles much larger than capybaras, so it's probably not that rare. I think this is really cool because this capybara is basically a robot, and I have a theory that all of these movements are purely mechanical. There's almost nothing electronic controlling the capybara inside here. Fernando, who's a physicist and our head of content here, disagrees with me. He thinks there must be some tiny little chip that controls at least how long the capybara stays still before moving its nose. So, which one of us do you think is right, huh? Let's start by analyzing this animal's movement. I'm shooting in slow motion at 240 frames per second, which is 10 times slower than normal. Check this out first. It moves its back leg, which pushes the animal forward. Then the front leg stretches out, completing the movement. That way, when it lands, it's already repositioned, allowing the front leg to pull back and the animal to move even further forward. It might sound silly, but timing is crucial when inventing a small machine like this. Shall we begin the animal's autopsy? Look, I'll tell you something, this is really well made. It's not that easy to figure out where to start taking it apart. This is going to be a delicate operation, so I'm going to use some surgical instruments I bought at an auction to try to remove the capybara's skin without damaging what's underneath, because I want it to work perfectly with just the skeleton. And look how crazy this is. This is really weird. There's a mini capybara rug and this very strange creature. Let's see this creature working without the skin. First thing, it's really strange because we associate this with the real animal, right? It looks like a capybara skeleton. I don't support hunting capybaras, but her rug is cute, Back to the technical side, it runs on 2 batteries here in the belly, and inside you can see a small motor, probably with a reduction gear to slow the motor down, first thing. Then the snout has a lever here at the front that makes it lift up, and it's controlled by the motor. Look, it's a bit hard to see, so I'm going to try some orthopedic surgery here and open up the side of the thing so we can see it working from the inside without breaking it. I think now you're going to want to give this a thumbs up. Look closely here in the middle. We have a gear. It has 2 levers attached to it. The front one controls the Capybara's snout, and the back one controls this bellows. This little accordion-like part is the whistle that makes the sound. And up here, we have that same kind of whistle you find in many squeeze toys, like those little mice you buy at pet shops. So the same wheel controls both of these things, but it stops at a certain point. It only works when the legs are still. Now let's try to understand how the legs move. There's a lever that connects one leg to the other, kind of like the bar that links one wheel to another on a steam locomotive. So, when the back leg moves, the front leg moves in the opposite direction. To see what makes the legs move, I need to remove this set of legs. Then we can see this little crank right here. It's really tiny. I was trying to take it apart while keeping everything working. But at this point, I'm not sure that's still possible. There's no mystery with the legs connected directly to the power here without a resistor, actually. The only thing I still can't figure out is why sometimes the legs turn on, and other times the nose turns on together with the whistle. Is there some kind of electronic timer in here that randomly activates one or the other? I doubt it. There's a kind of gearbox in here. This is the reduction I mentioned earlier. The motor shaft is connected to a much larger wheel. That means the motor spins a lot, but this wheel spins much less, reducing speed and increasing torque. I need to remove more parts to understand this gearbox. I painted the gears to make it easier to follow. Let's take a closer look, LD. This green set is what controls the snout and the sound, and the red set is what controls the legs. And you'll notice there's also an orange-colored set. At one point, it engages with the green set and drives, and then it switches to the red set. So at one moment it controls the green, and at another moment it controls the red. It keeps alternating between the two. If we slow this down and zoom in, you can clearly see that gear. It slides from one side to the other, and a small spring brings it back to its original position. So far, everything makes sense. The small orange gear first engages the green one, then shifts to engage the red one. That's what makes it activate the snout at one moment and the legs at another. But hey, this is manual do mundo. That alone doesn't solve it. What makes this orange gear change position on the other side of it? There's another gear with a slot in the middle, and it has a twin that's exactly the same size. It's right there. The 2 gears separate and come together, separate and come together. That's where the secret is. I think I'll need to cut some cardboard to help explain this, since everything here is so tiny. This Capybara is an engineering marvel. I reassembled that orange system right here. So if we look closely, what we see is the small gear is the one that shifts position to engage either the green or the red set. It's connected to a larger gear at the back, which has an almost identical twin. The two spin together, or almost together. The shaft coming from the motor reduction sits right here, touching both gears at the same time, but one of them is slightly smaller than the other. The result is that one spins faster than the other. On one of the gears, there's a kind of ramp, a little pin that fits into a slot on the other gear. Now let's put both together and see how it works. 11. So, imagine this top assembly spinning a little faster than the bottom one, but the top spins faster. At this point, the 2 gears are locked together. The moment the pin starts to be covered, when it leaves the slot, the 2 gears separate. They're still spinning together, but the top one is spinning faster until there's a moment when the pin lines up with the slot again. Then the small spring pushes the gear back to its original position. It keeps spinning. The pin re-engages. The slot ends. They separate and keep spinning until the pin meets the slot again. They come together. They separate. They come together. They separate. over and over again. And that's the secret of the timer. When the two gears are together, the legs move. When they're apart, the snout moves, and then it switches back again. Conclusion. There is absolutely no electronic control here. It's all mechanical, everything carefully designed to work, without a chip, without a transistor, without anything electronic at all. So, now that we've admired the inside of this technological marvel, how about we put a few more volts into the remaining Capybara? No batteries. I'm going to use a bench power supply that Mari's dad gave me, which goes from 0 to 18 volts. Just so you get an idea, the Capybara normally runs on 2 batteries, which gives about 3 volts. So that means we can multiply the voltage by 6. Let's connect it directly where the batteries go. 2 volts, which is a bit below the batteries. Now, let's go up to 3 volts. 3.5. That's already a pretty agitated Capybara, right? Aha. Should we push it further? 4 volts. Is it broken already? We barely played with it. Give the Capybara mouth to mouth! Do you think we'll need to open it to fix it? I only know how to open things to break them, not to fix them. Now that I know Capybaras, what do you think got stuck in this one? Huh? Something was jammed. I'll put it back in place now. Who said we don't improvise here too? This is just to make the soldering iron heat up faster. 1.5 volts. It's slow. See, really gentle. Let's give this Capybara a bit of adrenaline. 2 volts. 3 volts. Now it's basically the same as the battery. Let's push it a little further. 3.5 volts. 4 volts. Shall we try 4.5? 5 volts. 5.5 volts. It's starting to smell burnt. 6 volts. That's twice as much. Capybara, 6.5 volts. And the leg stopped, but the snout and the noise keep going. Should we keep going? 8 volts. 10 volts. This Capybara is going to explode. 12 volts. At 18 volts, it started to smell really strange. The motor might fail. I'm scared. The Capybara feels hot. Intensive care unit beeping sound. The end. If this isn't worth a like, I don't know what is. Look, taking apart cool toys like this is something we've done many times here. The last really cool one we recorded was when we figured out how those gel ball machine guns work. The mechanism is really cool.